Hello student, how are you all? I hope you all are doing good. I'm Pooja Tripathi, your teacher. So student, we have learned about the shapes. We have learned about 2D shapes and 3D shapes. So in this chapter, we are going to learn about the different shapes, their properties. All this we are going to learn in this chapter. So start with the quadrilaterals and their properties. Our learning objective in this chapters are quadrilateral, rectangle, square, parallelogram, rhombus, kite and trapezium. So about all these shapes we are going to learn in this chapter. So we are going to start with a quadrilateral. So what is a quadrilateral? A quadrilateral is two-dimension closed shape formed by 4 straight line segments. So quadrilateral is a two-dimension closed shape figure. It's two-dimension and closed figure made up of 4 straight line segments. It has 4 corners, that is called vertices, and 4 interior angles. For examples, all of such a shape shown in the figure 4.1. You can see in figure 4.1. These are the examples of quadrilateral. So in simple language, quadrilateral is a closed figure made up of 4 line segments. The word quadrilateral, that is derived from the 2 Latin word. Quadro means quadro and that meaning 4. Quad means 4 and latus meaning sides, means a figure made up of 4 line segments. Thus the name itself tells us that the shape has 4 sides. Here you can see in figure all these figures are quadrilateral. Now quadrilateral come in many forms such as square. Square is also quadrilateral, rectangle is also quadrilateral, trapezium, kites, rhombus, all these are quadrilaterals. Now, although their properties may differ, the basic feature of 4 sides and vertices and 4 angles remain the same. Now, the diagonals of the quadrilateral. Now, we'll talk about the diagonals of the quadrilateral. The diagonals of the quadrilateral is the line segments that connect any 2 vertices. So, diagonal that connect any 2 vertices, opposite vertices, and not the next to each other. In simple words, it join opposite corners. So that makes the quadrilateral. No matter what kind of quadrilateral it is, every quadrilateral always has exactly 2 diagonals. Clear? In a quadrilateral, there are only 2 diagonals. For example, in the quadrilateral shown in the figure 4.2, the diagonals connect the. Here you can see, this is a quadrilateral SR or PQRS and these are the vertices QR and SP. These are the side SR, RQ, PQ sides. These are the angle and the line that joining the opposite vertices, that is known as the diagonals. Now components of the quadrilaterals. Let us understanding the different parts of the quadrilateral using the quadrilateral PQRS in the figure 4.2. 4 sides. The quadrilateral has 4 sides. You can see PQ, QR, RS and SP are the 4 sides of the quadrilateral. 4 vertices. The corner where? The sides means that is P, Q, R and S. They are vertices of the quadrilateral. Now 4 angles, each vertex from an angle, angle P, angle Q, angle R and angle S. Now closed shape, all the sides joins end to end and form the closed figure enclosing the area. 2 diagonals, these are the 2 diagonals. The quadrilateral has 2 diagonals, PR and QS. These diagonals help to studying the additional properties such as symmetry, congruence of triangles and the division of the quadrilateral into the smaller shape. Now angles and property of the quadrilateral. You already know that the sum of the interior angle of any triangle is 180. From angle sum property we know the sum of all the angles of triangle is 180 degree. But what happens when the shape has 4 sides instead of 3? In quadrilateral we know there are 4 sides, so what is the sum of all 4 angles? To understand the angle sum of the quadrilateral, let us perform the simple hands-on activity. So this is the activity. Here we have to take a sheet of paper and draw any quadrilateral such as M and OP. We will take a paper and we'll draw any quadrilateral. Shade the color of 4 angles using 4 different colors so that they are easy to identify. Now carefully cut out the quadrilaterals and then cut its 4 corners, means 4 angles. Now place the 4 cutouts angles so that their vertices meet the single point, like this. So what will we see? So here we have cut all the 4 corners and placed it like that. What do you observe? When the 4 angles are placed together around the point, they form the full turn, like a complete circle. The full turn measured 360 degree. So that clearly shows that the sum of all interior angles of the quadrilateral is always 360 degree. Now angle sum property. For quadrilateral M and OP, the sum of all 4 angles, interior angle M and O and P, that is 360 degree. This rule applies for every quadrilateral, whether it is square, rectangle, kite, trapezium, rhombus or any irregular 4-side figure. Why does this happen? Because the quadrilateral can divide into 2 triangles. Each triangle has an angle of 180 degree. So 180 plus 180, 2 triangle, total is 360 degree. Now we'll take an example here. The interior angle of a quadrilateral are given in the ratio 2, ratio 3, ratio 5, ratio 6. Find the measure of each angle. So we know the sum of all interior angle of quadrilateral 360 degree. Let the 4 angle is 2K, 3K, 5K and 6K. So adding them together, we'll get 16K equals to 360 degree. So K, the value of K is 22.5 degree. Now to find the angle, first angle 2K means 22.5 into 2, that is 45 degree. Second 3K, 3 into 22.5 degree, 67.5 degree. Then 112.5 degree and 135 degree. Therefore the 4 angles measure 45, 67.5 degree, 112.5 degree and 135 degree. Clear? This is how we can find out all the angles of quadrilaterals. So practice all the examples. Next is quadrilateral form the large family of the 4-side shape. They are grouped into different type of depending on the side of length, like equal, unequal sides, opposite pair, etc. Angles measure right angle, acute, obtuse. What kind of angle is there? Their combination. Next is parallel side, 1 parallel side, 2 parallel side or no side is parallel. Diagonals, that is equal, perpendicular or bisecting, etc. Example includes rectangle, parallelogram, kite, rhombus, square and trapezium. All these are quadrilaterals. Each type has its own unique properties which help in solving geometric problems and identifying the shape in real life structure. First is rectangle. Rectangle is also quadrilateral. It is a special kind of quadrilateral that follows 2 important conditions. What are these conditions? All 4 angles are right angle, means each measuring 90 degree. Each pair of opposite sides have the same length, meaning the top and the bottom sides are equal and left and right are equal. Clear? Means opposite sides are equal. Here you can see a rectangle PQRS. In this opposite side means PQ is equal to RS and RQ is equal to SP. Because these features, rectangle appear everywhere around us, in doors, books, mobile, screen, tables and many everyday objects. Next, properties of rectangle. Let us explore the important characteristic of the rectangle using the figure of rectangle EFGH. Here a rectangle EFGH is given. Now property, opposite sides are parallel. So what is given to us? Here a rectangle EFGH in which we know each angle is of 90 degree, right angle. So we need to prove that EH means this side is parallel to this side and EF is parallel to GH, means opposite side, we need to prove that opposite sides are parallel. Now, consider the side EH and FG. Take a line segment EF as the transversal crossing them at the point E and F adjacent angle. So, we know the adjacent angle, that means angle E. This is the angle E, that is 90 degree. Here what we are doing, the line segment EF, this is the line segment EF as the transversal crossing. So, E and F are adjacent angles. So, angle E is 90 degree, F is also 90 degree. Add them together, 90 plus 90 will get 180 degree. On the same side of transversal, if the interior angle add up to 180 degree, the two line must be parallel. So, in the same side of transversal, interior angles sum is 180 degree, that we can say that lines are parallel. Therefore, EH is parallel to FG. Using the same reason, we can prove that EF is parallel to GH. So, what is the conclusion? The opposite side of any rectangles are always parallel. That we have proved here. Now, property 2. Opposite sides of rectangle are equal in length. So, what is given to us? Rectangle PQR is given. All four interior angles are right angle, that we know. That means angle P, angle Q, angle R and S are 90 degree. Now, what we have to prove? We have to prove that PS equals to QR, means PS is equal to QR and SR or that is equals to PQ, that we need to prove. Now, construction, draw a diagonal QS. So, what we'll do? We'll draw a diagonal QS joining the vertices Q and S. This diagonal will divide the rectangle into two triangles, triangle PQS, this triangle, and the triangle QRQS, two triangles. Now, we need to prove that, we will prove that the two triangle PQS and RQS are congruent. So, we have to prove that these two triangles are congruent. Step 1, identify the common side. So, common side we know QS is equal to SQ, the diagonal shared by the both triangle. This is the common line. Now, step 2, identify equal angles. We know that PQ and QS they are alternative interior angles because PQ is parallel to RS, and angle PSQ and SQ are alternative interior angle because PS is parallel to QS. Now, step 3. Now, we will apply the congruency rule. Thus, in triangle PQS and triangle RQS, we have one side equal, that is QS common, two pairs of equal angles. So, we can say that the triangles are congruent by ASA, congruency. Therefore, we can say triangle PQS is congruent to triangle RQS. So, what is the conclusion? Since the corresponding parts of the congruent triangles are equal, we can say PS equals to QR and PQ equals to RS. Now, property 3. The diagonals of the rectangles are equal and bisect each other, that we have to prove. What is given here? Here a rectangle WXYZ with the diagonal, two diagonals are given WY and XZ, which intersect at the point M as shown in the figure. Here they intersect. Now, we have to prove that WY equals to XZ, means we have to prove that the diagonals are equal in length. WO equals to OY, XO equals to OZ. The diagonals bisect each other. That we have to prove here. Now, prove that the diagonals are equal. Consider the triangle. So, we will take two triangles, ZWX and YXW. Now, in rectangle WXYZ, we know that ZW, that is equals to XY. Opposite sides of the rectangle are equal. We know and angle W is equals to angle Y. 90 degree, all the interior angle are right angles, so they are equal, and WX equals to XW, that is the common side of triangle. That means two sides are equal, angles are equal, and again WX and XW are equal. That means we can say these two triangles are congruent by SAS congruency rule. Since the corresponding part of congruent triangles are equal, if the triangle are congruent, their corresponding parts are also equal. That means we can say WY equals to XZ. Therefore, the diagonals of the rectangles are equal in length. Prove that the diagonal bisect each other. Now we have to prove that diagonal also bisect each other. Now consider the triangle OWX and OZY. In rectangle WXYZ, WX equals to ZY, that is the opposite sides of the rectangle. Now angle O equals to angle O, WX equals to ZOX, alternative interior angles, because WX is parallel to ZY. Now angle X is equal to angle Z, alternative interior angles again. Thus we can say angle same hai, side same, and angles are same. So we can say that two triangles OWX and OZY are congruent by ASA congruency rule. So in congruent triangle, their corresponding parts are also equal. So we can say WO equals to OY and XO equals to OZ. This shows that each diagonal is divided into two equal halves by the point O. Now conclusion, diagonals of the rectangles are equal and bisect each other. Here we'll take an example. In rectangle RSTEU, the diagonals intersect at point O. The vertically opposite angles at the intersection is 40 degree. The triangle SOU, the base angle is labeled alpha and beta. These are the angles at S and U of the small triangle. Find the values of alpha and beta. So here you can see this is the rectangle RSTU. Diagonals are given and this angle is given to us 40 degree, and we have to find the value of alpha and beta. So in any rectangle, we know the diagonal bisect each other at are equal. Hence the intersecting point O. Two small triangles formed by the diagonals and are isosceles when their two sides form O to the two vertices are equal. Two sides equal, isosceles, given the vertically opposite angles at O is 40 degree. That is angles between the two equal sides of triangle SOU and O inside the angle at O inside the triangle SOU is 40 degree. Now triangle SOU, we know an isosceles triangle with the two equal sides. OS and OQ are equal. Therefore, the base angles are equal, means alpha and beta are equal. Now, we know from the angle sum property of triangle alpha plus beta plus 40 degree, that is equals to 180 degree. Now, we know alpha and beta are equal, so we can write it as A. Suppose we are taking it as A. So, A plus A, 2A plus 40 degree equals to 180 degree. So, 2A equals to 180 minus 40. This is 140 degree. So, value of alpha 140 upon 2, 70 degree. Therefore, alpha and beta both angle value is 70 degree. Clear? Practice all the examples. Next is square. Square is a special type of quadrilateral with two defining characters. What are the characters? All four interior angles are right angles, each measuring 90 degree. All four interior angles are right angle. All four sides are equal in length in figure 4.10. Suppose PQR is in square, then we have right angle means angle PQRNS, that is 90 degree. Equal side means all sides are equal, PQ, QR, RS and SP. These two conditions fully described in square. Important note, a square satisfies every condition required to be a rectangle, but with one addition restriction, all sides of square must be equal. Now, square as a special type of rectangle. The figure classified as a rectangle if all interior angles are right angle and opposite sides are equal length, that we will say it is a rectangle. Now, let's compare this with square. A square also have four sides. A square also have four sides and four right angles. So, it satisfies the first condition. That means it satisfies the first condition. Since all sides of squares are equal, its opposite sides are naturally equal. So, it satisfies the second condition also. Therefore, we can say every square is a rectangle because it meets both requirements of the rectangle. But every rectangle is not a square because rectangle do not require all sides to be equal. In the figure 4.11, the Venn diagram shows that the set of all square lies inside the larger group of rectangle. This is because of the square is simply the more specific type of rectangle with additional symmetry. Now, key understanding, since the squares meet all the condition of rectangle, every property of rectangle also applies to the square. This include opposite sides being parallel, diagonals being equal in length, diagonal bisecting each other and interior angles each measure 90 degree. All these conditions applies. Now, a square simply adds one more feature, all sides equal, making it more regular symmetrical than the general rectangle. Now, properties of square. A square has several important characteristics that help in identifying the study it. Some of the features define the square while other naturally follow from the definition. So, properties of square. Property 1, all four sides of squares are equal in length. All four sides are equal in length. This is one of the fundamental conditions that make the quadrilateral a square if all four sides are equal. Now, property 2, each interior angle of the square measure 90 degree. Every corner of the square is right angle. Since these two rules are the part of the square definition, they do not require proof. The next set of properties arise from these definitions and can be logically proven. So that next property, property 3, opposite sides of square are parallel. A square, we know a special kind of rectangle. We already know from the study of rectangle that opposite side of rectangle are parallel, that we know. Since the square meet all the requirements of the rectangle, this property applies here automatically because in rectangle opposite sides are equal. Thus, square WXYZ, WX is parallel to YZ and XY is parallel to ZW. Now, property 4, the diagonals of the square are equal and bisect each other and meet at 90 degree. Let us consider square WXYZ. We'll take a square WXYZ where the diagonal WY and XZ intersect at the point M. So, they intersect at the point M. So, we need to prove that WY, that is equals to XZ, and WM equals to MY and XM equals to MZ, means each diagonal cut into two equal parts. That we have to prove here. The diagonal is intersect at right angles, means at 90 degree. We have already learned in any rectangle diagonal XY and WY equal, that we have proved earlier. Diagonal XZ and WY bisect each other, that we know. Therefore, WY and XZ equal and WM and MY and XM and MZ are true. Now, we only need to prove that diagonals meet at 90 degree because all these things we have proved earlier. Now, consider a triangle WXM. WXM. this triangle, and WMZ. WMZ means these two triangles here we are taking. We know that WX equals to WZ, all sides are squares are equal, that we know, and WM equals to WM. Common sides, this side is common. XM equals to MZ, equal half of diagonals. That means triangle WXM and triangle WMZ are congruent. Hence, their corresponding angle WMX and WMZ are equal. Also, there lies the same straight line XZ. So, we can say that WMX and WMZ equals to 180 degree. So, both are equal. So, we can write this, and each angle 180 degree upon 2, that is 90 degree. This proves that the diagonal bisect each other of the square are perpendicular bisector of each other. Property 5. Diagonals of the square bisect its corner angle. This means the diagonals split the right angle, because the corner angle, each angle is 90 degree, into two equal parts, that is 45, each angle 45 degree. Let us prove that given a square WXYZ. In figure 4.12 you can see, consider that the diagonal WY. Look at the triangle WXY. Angle X 90 degree, and we know WX equals to XY, side length of the square. Therefore, the triangle WXY is an isosceles right triangle, means two sides are equal. In such triangle, the two angles are the base equal, means two sides equal, so two angles are also equal, means WYX and angle YWX are equal. Using now angle sum property, two angles plus 90 degree 180 degree. Now these two angles are equals to 90 degree. Since they are equal, so 2WYX equals to 90 degree. So each angle is of 45 degree. So the diagonal WY divides 90 degree angles are at Y into 45 and 45 degree. The same logic applies for the other. Now, thus the diagonal WY divide 90 degree angle into Y into 45 and 45 degree. The same logic applies for the other diagonal XZ and the remaining angles. Therefore, the both diagonals split the interior angle exactly in half. Here we will take an example. The diagonals of a square measure 22 centimeter. Now we have to find the length of the other diagonal and the distance from any vertex to the center of the square. So we know from the property 4, diagonals of squares are equal. Therefore, the second diagonal is also 22 centimeter. The diagonal bisect each other. So the diagonals from the vertex to the center of the half 22 upon 211. So the length of the second diagonal is 22 centimeter. And the distance from corner to center is 11 centimeter. So practice all the examples. Now steps of construction. Draw the diagonal. How can we draw the diagonal? That we'll learn here. Draw a line segment PR that is exactly 5 centimeter long. So we'll draw a line segment that is 5 centimeter long using the ruler. Mark the midpoint M, measuring 2.5 centimeter either end, exactly half. Now, thus the M is the center of the square. Now step 2, construct the perpendicular line. We have to construct the perpendicular line using the protractor. Place its center at the point M on the segment PR. So here we'll put the center. Draw the line through the M that form at 90 degree. 90 degree will draw a line with angle with PR. Extend this is perpendicular line above and below PR. Extend it. This line will contain the other diagonal of the square. Here you can see this is line segment 5 centimeter. Will take the midpoint M and will draw the line which will divide into two parts and will join them like this. And this is step 3. Mark the endpoints of the second diagonals. With the compass set radius 2.5 centimeter, what we'll do? We'll take the radius 2.5 centimeter and we will like this. We'll make the mark and then again the other mark, half of the diagonal, and place the compass at M and draw the arc that meets the perpendicular line. Where the line cut these points Q and S. Label these intersection Q and S. Form the square. Now connect the point P to Q, P to S, R to S and R to Q. The quadrilateral PQRS is the required square. Now why this figure is square? The construction guarantees the square because PR and QS is equal in length. Both are 5 centimeter. They intersect each other at right angles, bisect each other at M. These three properties, equal diagonals, perpendicular diagonals and the diagonals that cut each other in half, uniquely determine square. Based on these properties, we can say this is a square. Thus the final figure PQRS is a perfect square. Practice all the examples given here. Next is learning point 4.1. Practice all the questions given here. Next is parallelogram. So we have learned about the rectangle, we have learned about the square, all the properties. Now we'll learn about the parallelogram. Earlier we learned that the rectangle is the type of quadrilateral where all right angles and the opposite sides equal in length. Another important property of the rectangle is that its opposite sides are parallel. But what if we focus only on the idea of parallel opposite side without worrying about the angles being right angles? So here we are talking only about the parallel opposite sides. Can the quadrilateral still exist in such case? So here a figure is given, figure 4.15. Now imagine you have a rectangle PQRS and you push gently one side of its top corner, tilting the shape slightly. As the rectangle leans, the angles at the corner no longer remain 90 degree. Here you can see if you push one side, the angle will not remain the 90 degree, but the opposite side stay parallel and remains equal length. But still the opposite sides are equal and equal in length. This new slightly tilted or slanted shape, it's called parallelogram. This is called parallelogram. Essentially a parallelogram is the broader category of the quadrilateral and rectangle, just the special type of parallelogram where the angles happen to be right angle. In simple terms, the parallelogram is the quadrilateral in which both pairs of opposite sides are parallel. For example, in the parallelogram PQR shown in the figure, we can see PS is parallel to QR and PQ is parallel to RS. The diagonals of the parallelogram which connect opposite corner are PR and QS. Opposite corner PR and QS. Let's now examine some key properties of the parallelogram and understand how it behaves differently from other quadrilaterals. So properties of parallelogram. Property 1. Adjacent angles of the parallelograms are supplementary and opposite angles are equal. So what is given to us? A parallelogram PQRS shown in the figure 4.17. This is the parallelogram PQRS. Now we have to prove that P and Q, adjacent angle that are supplementary, means their sum should be 180 degree, and Q and R 180 degree, R and S 180 degree, and S and P 180 degree. And we have to also prove that angle P means opposite angles are equal. Now proof. Adjacent angles are supplementary in the parallelogram PQRS. Opposite sides are parallel. PS is parallel to QR. Consider PQ as the transversal line. So here we are considering PQ, this line, as a transversal. Clear? By the property of interior angle on the same side of transversal, we have PQ equals to P, angle P plus angle Q. Same side, 180 degree. That means, similarly taking QR parallel to PS, the transversal RS, here transversal is RS, so we can say angle R plus angle S equals to 180 degree. Taking PS parallel to QR, the transversal SP, we can say angle S plus angle P 180 degree. Finally, PQ parallel to RS, we can say angle Q and plus angle R 180 degree. So opposite angles are equal. From the above we know that angle P plus Q 180 degree, Q plus R 180 degree. Subtracting the common angle Q from both we get. If we will subtract common angle Q from both, we will get angle P equals to angle R. Similarly, using angle P plus R 180 degree and angle P plus Q 180 degree, we will subtract angle L P, so we will get angle S equals to angle Q. So conclusion, in an parallelogram, each pair of adjacent angles add up to 180 degree, means supplementary. Their sum is equal to 180 degrees, so we will say a supplementary angles, and opposite angles are equal. Now property 2, opposite sides of parallelograms are equal in length. Given so what is given to us? Parallelogram PQRS. Here you can see this parallelogram PQRS. We have to prove that PQ equals to RS. PQ and RS are equal and PS and Q are equal. Constructions, draw the diagonals. So for that we will draw diagonal SQ. Clear? Connecting the vertices Q and S. It divide the parallelogram into two triangles, 1 and 2, two triangles. Clear? Triangle PQS, triangle, this is triangle PQS and this is triangle RSQ. Clear? Now proof. Consider the triangle PQS means this triangle PQS and triangle RQS. Since PQ is parallel to RS and QS is transversal, here the QS is transversal. So we can say angle PQS equals to QSR. Alternative angle, angle Q and angle S. They are alternative angle, we can say. So since PS is parallel to QR and QS is a transversal, that means angle PSQ and angle SQR. Alternative interior angle, and QS is the common side for both the triangles. By the angle side angle ASA congruency, we have that the triangle PQS and RQS are congruent. Therefore, the corresponding sides are equal. That means we can say PQ equals to RS and PSR equals to QR. Now property 3, diagonals of the parallelogram bisect each other. So what given to us? Parallelogram PQRS with the diagonal PR, two diagonals PR and QS intersecting at the point O is given to us. We have to prove that PO equals to OR and QO equals to OS. Proof, consider the triangle, two triangle POQ and triangle ROS. These two triangles. In the parallelogram, we know that the opposite sides are equal. That means PQ and RS and PS and Q are equal. Clear? Since PQ is parallel to RS and PR is the transversal. PR is the transversal. That means angle PQO and RSO are equal. Alternative interior angle, angle Q and angle S. Since PS is parallel to QR and QS is transversal, so we can say angle PSQ and SQ are alternative interior angles. PR equals to PR and QS equals to QS. These are common diagonals. By ASA congruency, triangle POQ and ROS are congruent. Hence, the corresponding side of these congruent triangles are equal. That means we can say PONOR and QNOS are equal. Conclusion: the diagonals of the parallelogram divide each other into two equal halves, meaning they bisect each other at their intersection point. Rhombus. So earlier we have learned that in the parallelogram the opposite sides are always equal in length. So in parallelogram opposite sides are equal in length. Now let us explore the deeper what if the idea. What would happen if we took a parallelogram and added an extra condition that all four sides must be equal? So same as parallelogram, but here we have added a condition that all four sides must be equal, not just opposite ones. Like in parallelogram, opposite sides are equal, but we have added the condition that all four sides should be equal. To understand this picture of the normal parallelogram, its opposite sides are equal and parallel, but the angle can vary. Now imagine slowly adjusting the shape by pulling and pushing at the corners until every side becomes the same length. The figure that emerged look like the square and has been gently tilted or pushed sideways. The new figure created from a parallelogram by making the sides equal is known as rhombus. So this new figure is known as rhombus. So rhombus is a special type of parallelogram in which all four sides are congruent. In the example shown in the figure 4.21, the rhombus PQRS has sides. So the sides are PQ equals to QR equals to RS equals to SP, means all four sides are equal. Since the rhombus begin with the basic structure of parallelogram, it still belongs to the parallelogram family. Therefore, every rhombus is a quadrilateral with the following feature. Opposite sides are parallel, just like any parallelogram. All four sides are equal, which make it more specific than the regular parallelogram, and angles need not to be right angle unlike a square. So all these conditions meet in rhombus. Clear? Now it appears like a slanted, tilted or tilted square. We have seen in the figure. In simple word, the rhombus is a four-sided figure with all sides equal and opposite sides parallel. Now we will see the properties of rhombus. So we already know that the rhombus belong to the family of parallelogram because every property of the parallelogram automatically applies to the rhombus. Let us review these basic properties first. So here you can see this is the rhombus. Now we will see the general properties inherited from the parallelogram. So property 1, opposite sides are parallel. A rhombus has two pairs of sides that runs parallel to each other and opposite sides are parallel. Next, property 2, opposite angles are equal. In rhombus, opposite angles are equal. The angle that face each other have the same measurement. Property 3, adjacent angle. In rhombus, the adjacent angles are supplementary, means their sum is 180 degree. Any two angles that share the common side add up to 180 degree. Now property 4, diagonals bisect each other. When the diagonal cross, each diagonal cut the other into two equal parts, means they bisect each other. Now properties of a rhombus, not true for all the parallelogram. These property applies in the parallelogram, but now the properties of rhombus that not true for all parallelogram. Although the diagonals of any parallelogram bisect each other, they are not always perpendicular. The rhombus, however, is unique. Its diagonals meet at right angle, means 90 degree. This leads to the important additional property. Property 5, the diagonals of the rhombus intersect at 90 degree. In other words, the diagonals of the rhombus are perpendicular bisector of each other. They bisect each other at 90 degrees, so they are perpendicular bisector of each other. Proof of the perpendicular diagonals. Let us consider rhombus PQRS where the diagonals PR and QS. These are the diagonals intersect at the point M. Now we need to show that PMQ, the angle at the point of intersection is 90 degree. Now what is given to us? PQRS is a rhombus, all sides are equal, diagonals are given PR and QS, they bisect each other at point M, and we have to prove that PR is perpendicular to QS. Now proof, look at the triangle. So here we will take two triangles, PMQ and RMQ, formed by the diagonals. We know that PQ equals to QR and RS equals to SP. All four sides of rhombus are equal. PM equals to MR and PQ equals to RQ. And QM equals to QM, common sides. Thus, these two triangles are congruent to each other by SSS congruency rule. Since the triangles are congruent, their corresponding angles are equal. That means angle PMQ and RMQ are equal. But PR is a straight line. So PMQ plus RMQ total is 180 degree. Linear pair of angles, since the two angles are equal, so each angle will be of 90 degree. Thus, we have proved that the diagonals of the rhombus are perpendicular to each other. That we have proved here. Now, property 6. The diagonals of the rhombus bisect its angle. One of the remarkable features of the rhombus is that its diagonals not only bisect each other and meet at the right angle, but they also divide each interior angle into two equal parts. This is not true for all parallelographs, but it is always true for the rhombus, means the diagonals will divide the interior angle into two equal parts. Meaning, when the diagonals is drawn in the rhombus, it split the corner angle into two congruent angles. So here given is a diagonal PQRS in the figure 4.21, and diagonals are given PR and QS intersecting at the point M. Now, to prove that a diagonal PR are bisect QPS and QRS. Diagonal QS bisect PQR and PRS. Proof that the diagonals PR bisect two angles. Consider triangle. Here we will take two triangles QPM and SPM formed by the diagonals PR. Now we know that QP equals to PS. All sides of rhombus are equal. QM equals to MS, the diagonal bisect each other, and PM equals to PM, common side. Since all three pairs of corresponding sides are equal, that means we can say these two triangles are congruent by SSS congruency. Now, because the triangles are congruent, their corresponding angles are also equal. That means we can say angle QPR equals to angle SPM, PR bisect angle QPS, and QRP equals to angle SRP. Here PR bisect angle QRS. Thus, the diagonals PR divide the angle into angle at P and R into two equal halves. That we have proved here. Now, prove that the diagonal QS bisect two angles. Now, consider two triangle PQM and RSM in the figure 4.21. Again, we know that PQ equals to RS, all sides of rhombus are equal, PM equals to RM, diagonals bisect each other, and QM equals to MS, that is common side. QM equals to QM, common side, therefore, triangle PQM and RSM is congruent by SSS congruency. From their congruence, we can conclude that angle QPS equals to angle RPS and QSP equals to RSP. So the diagonals QS divide the angle at Q and S into two equal parts. So final result is both diagonals of the rhombus bisect its interior angle. Now we'll take an example here. In the parallelogram PQRS, the measure of the angle Q is given to us. Angle Q equals to 3y plus 12 degree. Now we have to find the value of angle Y, this angle. We have to find its value. Now we'll see the solution. One important property of the parallelogram is that the adjacent angles are always supplementary. That we know adjacent angles are supplementary. That means we can say angle Q and R, their adjacent angle, their total is 180 degree and angle Q is given 3y plus 12 degree. So we'll put the value. Now y equals to 3y plus 12 plus y. So that is 4y plus 12 equals to 180 degree. Now we'll subtract 12 from the both side. 4y equals to 168 degree. Y equals to 168 divided by 4, that is 42 degree. Therefore the value of angle Y will be 42 degree. Practice all the examples given here. You have to practice all these examples. Next is learning point 4.2. So here the questions are given. You have to practice all these questions. Next is kite. Now, a kite is a special type of quadrilateral identified by the length of its adjacent side. Now, you will see kite is also a quadrilateral. Its adjacent sides are equal. The quadrilateral is called kite when it has two separate pair of neighboring sides are equal in length. Means this and this sides are equal and this are equal. Now consider the kite PQR as shown in the figure. PQ equals to PS and RQ equals to RS. Here the diagonal PR. Join the two PR. Join the vertices where these equal side meets. Now here is an activity exploring the properties of the kite. Draw the figure. Draw a kite PQRS on the sheet of paper. Now draw both diagonals PR and QS and mark their intersection point M. This is the point M. Now measure the angles using the protractor. Measure the angles formed at point M by the intersecting diagonals. Now measure the diagonal segments. With a ruler, measure the length of the PM and MR, QM and MS. Now compare the measurement. What pattern do you notice? Cut and observe. Cut out the kite along its border, then cut it again along the longer diagonal PR to form two triangles. Triangle QRP and triangle SRP. So two triangles. Triangle PQRP. Triangle QRP, this one and the second one, these two triangles. Place one triangle on the top of the other. Do they match exactly? What can you conclude about the angles of Q and S? What does reveal about how the diagonal PR behave at the vertices P and R? So we'll cut the two diagonals and put it on each other and we'll see both diagonals. Can they match exactly? Yes, because adjacent sides are equal. Now we'll see the observation. From the activity you will notice that important fact, the diagonals that join the vertices between the equal pair of adjacent sides act as a perpendicular bisector or of the other diagonal, that is QS. The same diagonals also split the angles at the vertices that touches angle P and angle R into two equal parts. Now, properties of kite. So, property 1, the diagonal that connect the vertices joining each pair of equal adjacent sides is perpendicular bisector of the other diagonal, means 90-degree angle will form there. Property 2, the same diagonal, that is PR, also bisect the angle of those vertices. Thus, it divides the angle P and R into two congruent angles, means two equal parts. Next figure is trapezium. Earlier, we studied the quadrilateral in which both pair of opposite sides have the special relationship, such being equal or parallel. Now, let us explore the quadrilateral where the conditions are even more relaxed. So, the trapezium, this is the trapezium. What if only one pair of opposite sides are parallel and the other pair is not? What if? We know in parallelogram opposite sides are parallel. So, two pair of opposite sides are parallel, but what if only one pair of opposite sides is parallel and other pair is not? That led to the next important member of the quadrilateral family, the trapezium, also called the trapezoid in some region. The trapezium is defined as the quadrilateral that has at least one pair of parallel opposite sides. Only one pair of parallel opposite sides are there. The parallel sides are known as the base and non-parallel sides are called legs. Consider the new figure in the trapezium L, M and O. Here L, M and NO act as the base, while the LO and MN serve as the legs. So, sides which are parallel are called base and the other two sides are called legs. Now, properties of the trapezium. To understand the trapezium better, let us discover the key angles property through an activity. So, here we have to draw a trapezium. On the sheet of paper, draw a trapezium LMNO such that LM is parallel to NO. Now, we will measure the angles. Using the projector, measure or fold interior angle L, M and NO. Now, calculate angle sum along each leg. Add the angles lying on the leg LO, calculate angle L and angle O. Add the angles lying on the leg MN, calculate the angle MNN. What will observe? Observe your finding. What pattern do you notice in both sums? Conclusion of the activity, you will find that property 1, the sum of the interior angle on the same leg of trapezium is 180 degree. This is fundamental property of trapezium, that in trapezium the sum of interior angle on the same leg will be equal to 180 degree. Reason behind the property. Sides LM and NO are parallel to each and each leg act as a transversal. Here LM and NO are transversal and each leg, that is the transversal cutting across the two parallel base. From the geometry, the parallel lines when the transversal intersect two parallel lines, the pair of interior angle on the same sides of the transversal always add up to 180 degree, means they are supplementary. In trapezium L, M and O, L and O lie in the same leg LO and M and N, angle N, they lie on same leg MN. So, we can say L and O sum is 180 degree and M plus N is 180 degree. Now, isosceles trapezium. Just as we have isosceles triangle where two sides are equal, we also have the special form of trapezium that follows similar idea. An isosceles trapezium is the quadrilateral in which one pair of opposite sides are parallel and the remaining two non-parallel sides called the legs are equal in length. One side is parallel and other side is equal in length. that is called the isosceles trapezium. So, here you can see this is a trapezium. Imagine the quadrilateral PQRS, where PQ is parallel to SR or RS. The legs PS and QR. These are the legs. Non-parallel sides have the same length, but they have the same length. Such shape is known as isosceles trapezium. Now, properties of an isosceles trapezium. An isosceles trapezium shows all the regular property of the trapezium, but it also have the additional feature due to the equality of its length. Now, activity hands-on exploration. Draw an isosceles trapezium PQRS on the paper such that PQ is parallel to RS and PS, that is equals to QR. So, we have to draw a trapezium. Now, measure the pair of angles at the longer base, that is angle S and R. The measure of the pair of angle at the shorter base, that is angle P and Q. What pattern you observe? Now, draw both the diagonals PR and QS. Use the ruler to measure their length. What do you discover? From the simple activity, two important properties become clear. Property 1, base angles of an isosceles trapezium are equal. In isosceles trapezium, base angles are equal. The angle adjacent to the base are equal. Angles adjacent to the opposite base are also equal. Now, property 2, diagonals of an isosceles trapezium are equal in length. So, in trapezium PQRS, P, angle P and angle Q, angle S and R are equal. P is equal to Q and S equals to R. PR equals to QS. These facts can be proved formally using the triangle congruence. By using the congruency, we can prove that they are equal color and forming the right angle triangles. But for now, we will rely on the activity based observation. Clear? Here we will take an example. Find the value of angle Y. So, we have to find the value of Y. So, in the trapezium, here this is the trapezium, here MN is parallel to KL. Now, the angles on the same side of transversal are supplementary, that we know. That means the sum of angle M and L equals to 180 degree. So, we will put the respective value 4y plus 10 plus y plus 50 equals to 180 degree. 4y plus y, 5y, 50 plus 10, 60 equals to 180 degree. So, 5 equals to 180 minus 60, 120. Y equals to 120 divided by 5, that is 24 degree. Thus, the value of y is 24 degree. Clear? Next is learning point 4.3. You have to practice all the questions given here. Next is summary. The quadrilateral is a polygon of 4 sides and 4 angles. Types of quadrilateral include rectangle, square, parallelogram, rhombus, kite and trapezium. The rectangles opposite sides are equal and parallel of all angles are 90 degree and diagonals are equal. Square has all sides and all angles of 90 degree and diagonals are equal and perpendicular bisecting each other. A parallelogram has opposite sides equal and parallel, opposite angles equal and adjacent angles supplementary, the diagonals bisect each other. The rhombus have all 4 sides equal, opposite angles are equal, the diagonals bisect each other at the right angle, diagonals also bisect the angles. The kite has 2 pair of adjacent sides, 1 pair opposite angles are equal and diagonals are perpendiculars. A trapezium or the trapezoid has the least 1 pair of parallel side and non-parallel sides are equal. It is called the isosceles trapezium. The perimeter of the quadrilateral is sum of all 4 sides. The area depend on its type. Rectangle area equals to length into breadth, square area equals to side square, parallelogram area base into height. In rhombus or the kite, area equals to 1 by 2 into product of diagonals. Trapezium area equals to 1 by 2 into sum of parallel side into height. Diagonals are important property to identify the quadrilaterals. In rectangle, diagonals are equal, square equal and perpendicular, rhombus perpendicular, kite perpendicular, parallelogram bisect each other. Adjacent angles in parallelograms are supplementary. Quadrilaterals are 2D closed figure and the sum of the interior angles of any quadrilateral is 360 degree. The square has a special type of rectangle and the rhombus. The rhombus is special type of parallelogram. So student, here we end the chapter. In this chapter we have learned about the quadrilateral, different kind of quadrilaterals, their properties, all these things we have learned in this chapter. I hope all these things are clear to you. Now to practice it.